What's n as a positive integer if 133 to the power of 5 plus all those power of 5s equal n to the power of 5. So first of all, we have to get a rough, relatively nice estimation of the upper bound and lower bound of this. So first of all, if I get rid of this, and this, so this is bigger than that. 133 to the power of 5 less than n to the power of 5. Less than 1. Right? We want to get as tight as an upper bound as possible. Right? The upper bound cannot be too big. So we can use number 27. Right? One thing we actually can notice is that because 27 times 4 happens to be 108. A little bit bigger than 84, right? If you multiply by 3, then it's going to be 81. 81 is less than 84, so this is what we want. And also 27 multiplied by 5 gives us 135. Again, a little bit bigger than 133. Okay? And also 135, a little bit bigger than 110 also. Right? So we can just easily use this as upper bound of this, and this. Right? So this must be less than, replace 133 with 135. Again, 110 with 135. Again, replace 84 with this. 5. And copy down that. So like I said, 135, right? It's a multiple of 27, right? So what do we factor out 27? 27 to the power of 5. We're left with 5 to the power of 5. Right? Likewise, 5 to the power of 5. 108. Right? We're left with 4 to the power of 5. And here, it's just 1. Right? And so this happens to be, turns out to be multiplied by 7275. Right, that's the outcome of this sum. So again, we have to, because remember, we have to find out a relatively tight and nice upper bound, right? We have to come up with a number whose power of 5 turns out to be a little bit bigger than this. All right, we can try 1, 2, 3, 4, 5. 5 to the power of 5 is less than this, but 6 to the power of 5 happens to be 7776, right? A little bigger than 7275. Like I said, 5 to the power of 5 is no bigger than that. But this is a little big, so we can, again, a nice upper bound. Six to the power of 5. All right, so that way we just combine 27 and 6. So 162 to the power of 5. Right? That's a relatively nice and tight upper bound. So again, this is bounded between this and that, so which tells us that n has to be bounded between 133 and 162. Or we can say n is bigger than or equal to 134 and less than or equal to 161. Right? This is perfectly reasonable. So next we say, how can we further estimate? Because there's only 28 possible candidates here, right? 28 candidates to be determined. We're going to rule out some of the numbers. So again, we use number 2 to divide this. In other words, we want to find out what's the remainder if we divide n to the power of 5 by 2. All right, so we divide each. So in fact, this is even. This is also even. This is obviously odd. This is also odd. So even plus odd plus odd. Of course, even. So must be even. So n to the power of 5 is even. So n has to be even. No problem. All right, so in other words, n is mod 2, right, congruent to 0. Next, of course, we use mod 3. We use 3 to divide. I want to find out n is congruent to what? Mod 3. Right? Okay, we divide 133 by 3. We get what? So I think it's 1. So 110 divided by 3. Okay. I think it's 2. In other words, negative 1. Like 84. Congruent to 0, right? Divisible by 3, obviously. So 27 also divisible by 3. So this is good, because now I can work out, I can do to the power of 5. Obviously, I raise to the power of 5. Still congruent to 1. Still congruent to negative 1 to the power. Still negative 1. 0, 0, nothing. 0. Mod 3, right? So n to the power of 5 is divisible by 3. So n must be divisible by 3, right? If it has a remainder of 1, when you raise it to the power of 5, right, cannot be divisible by 3. Right? If n has a remainder of 2, when you raise it to the power of 5, of course, cannot be divided by 3. It's only when n is also divisible by 3, right? So we know that congruent to 0, mod 3. Right? So this is an outcome, right? There is another. It turns out that n is both divisible by 2 and 3, right? So 2 divides n, 3 divides n. Also, the GCD of 2 and 3 is 1, right? So that coprime, therefore, their product 6 has to divide n as well. Now let's continue with divisor 5. I divide 5 into this, in other words, into this. So 133 congruent to what? I think it's 3, in other words, negative 2. And also 110 must be, of course, divisible by 5. 84 is what? I think it's 4. In other words, -1. And also 27. I think it's 2. Right? So all we have to do is to raise to the power of 5. Right? 5, 5, 5, 5. So, in other words, n to the power of 5 must be congruent to -2 to the power of 5 plus 0 plus -1 to the power of 5 plus 2 to the power of 5. And what is that? This and that can just cancel out. -1, right? Mod 5. So it turns out that n to the power of 5, if divided by 5, we have a remainder of -1. In other words, 4. So you can try all the possibilities, right? You can try if n is congruent to 0, 1, 2, 3, 4. The only possibility is that, so skip all the details. The only possibility is n has to be congruent to 4, in other words, -1 as well. Mod 5, right? That's the conclusion, just quickly. So what can we learn from here? Because we've already known that concluded 6 divides n, right? So I can just write n as 6 times k, right? K is some integer, or a positive integer. If that's the case, I want to know that, because remember, there are only 28 candidates, right? And 6, right? Divide 6 times 5, 30. Right? What if we divide by 30? Right? What's the remainder? So I want to know n is equal to 30 times m plus r. I want to know what the remainder is, right? So divided by 30. So at the same time, right, if I factor out 6, becomes 5 times m plus r over 6. At the same time, n, like I said, n is divisible by 6, right? So n can be written as a multiple of 6, 6k. But it can be also written into this, right? 6 times that. So which means, right, this must be also a positive integer. Right? Since m is already a positive integer, right? So this must be also a positive integer. Right? So which means r is also, so which means 6 divides r as well. R is a multiple of 6. And then we look, so the only possible remainder, r, could be perhaps 0. Right? Since the multiple is 6, so in other words, 6, 12, 18, 24, of course, cannot be 30. Because the remainder is like cannot be larger than 30. I'm talking about positive, non-negative remainder, right? From 0 all the way up to 29, so cannot be 30. So these, how can we can rule out some of the candidates here. All right, how can we? All right, like I said, n divided by 5 has a remainder of -1 or 4. Right? So here, n can be written into this, right? But this, first of all, 30m can be divided by 5. Right? It's a multiple of 5. So the only question is that I require r, if divided by 5, must have a remainder of -1, right? This is my conclusion. First of all, r is a multiple of 6, right? Then r must have a remainder of -1 or 4, right? Divided by 5. How can we? First of all, I can just easily roll out this one, right? This divided by 5 cannot have a remainder of -1. This divided by 5, remainder of 1, cannot be true. This divided by 5, remainder of 2, cannot be true. Divided by 5, remainder is 3. This divided by 5, remainder is 4. But 4 is just like remainder of -1. So this is fine. Right? So it turns out that the only form of n must be 30m plus 24. Right, m may be some positive integers, right? But 24 is sitting here, but so it's a remainder, right? 24 remainder. So like I said, there is only 28 candidates, right? From here to there. Right, divisor is 30. Of course, 28 is less than 30, so that means each candidate would have a unique remainder when divided by 30. Since we already know n remainder is 24 divided by 30. Right? So theoretically, n could be many possibilities. Right? There's many numbers with a remainder of 24 if divided by 30. But because right, only one, like I said, only one candidate has the remainder of 24 here, right? Because each of them has a unique remainder, right? 24 of them, like, but divisor is 30, right? So n can only be. So first of all, I want to know 134 divided by 30. What's its remainder? So 4 is 120. So here's the remainder. But I want a remainder of 24. So I must have, so plus 10, so 144. That's the